This is the final review quiz, part 3, the third and final part. Number 1, we are looking at the function f of x is equal to negative 2x cubed plus 27x squared minus 84x plus 6. It has one local minimum and one local maximum. We need to find them. So we need the derivative, which is negative 6x squared plus 54x minus 84. And we'll need to find the critical point, so we'll set that equal to 0 and solve. I recommend using the quad program in your calculator to solve it, or you can solve it by hand. So A is negative 6, B 54, and C negative 84. So we get two critical points, one at 2 and one at 7. But we need to know which one is where it has a local max and which one has a local min. It's not necessarily the smaller number a min and the larger one a max. So you can either use the first derivative test or the second derivative test. With this type of function, I would recommend the second derivative test. So the second derivative is equal to negative 12x plus 54. So if we plug in 2 to that second derivative, we get negative 24 plus 54, which is 30. It's positive, and so if the second derivative is positive, oops, I drew that wrong. Eraser. Here we go. Shoot, it won't let me erase. Okay, well, it's supposed to be positive, smile, and we have a minimum. And then plug 7 into the second derivative, so negative 12 times 7 plus 54. So that's negative 84 plus 54, it's negative 30. So 2 minuses, frowny face, and that makes it a maximum. So the maximum is at 7, the minimum is at 2. We still have to find what the min and max are. And to do that, we're going to plug in 2 and 7 into the original function. So f of 2 would be negative 2 times 2 cubed plus 27 times 2 squared minus 84 times 2 plus 6, and that's equal to 55. And then if we plug 7 in, we should get, oh, I think I have this backwards. I'm sorry. This one's negative 70 and this one's 55. So f of 7 is 55, f of 2 is minus 70. So your min is the minus 70, max the 55. Number 3. A baseball team plays in a stadium that holds 58,000 spectators. With a ticket price at $10, the average attendance has been 22,000. When the price dropped to $9, the average attendance rose to 29,000. Assume that attendance is linearly related to ticket price. So that means that your ticket price is your independent variable. So you get the 2 points, 10, 22,000, and 9, 29,000. And it's linearly related, so we can get the slope and y-intercept to find the equation of the line. So it's 10 minus 9, or 9 minus 10 on the bottom. So we get negative 7,000 for our slope. And if we plug in the second point, then I get 29,000 plugging this into y equals mx plus b equals negative 7,000 times x, which is 9, plus b. And if we solve, we get that b is 92,000. So the equation that we just found, this is our price, and we get negative 7,000x plus 92,000. To get revenue, we just need to multiply everything by x. Because the price that you're selling things at times how much you sold will give you the revenue. So it's negative 7,000 x squared plus 92,000x. To maximize that, we're going to have to take the derivative. So our prime of x is negative 14,000 x plus 92,000. And then if we set that equal to 0 and solve, okay, so that's an x right there. Subtract the 92,000, divide by 14,000, you're going to get that x is 6.57. So that's the price that we want to charge to maximize the revenue. Number 4. Given the demand function d of p is equal to the square root of 4,000 minus 2p, find the elasticity of demand at a price of $47. So E of p is equal to the absolute value of p times d prime of p over d of p. So we need to find all sorts of things here. Let's start with the derivative. A better way to write this equation would be 4,000 minus 2p to the 1/2 power. It's better because it'll make it easier to find the derivative. So it's going to be 1/2 times 4,000 minus 2p to the negative 1/2 times negative 2. And to simplify that, negative 2 times 1/2 is just negative 1. So we get negative 4,000 minus 2p to the negative 1/2. And then we're going to go ahead and plug in the price that we're given, the $47. And we'll put that into the equation. So 4,000 minus 2 times 47, I get 3,906 for that. And then I'm going to take that to the power of negative 0.5. And then multiply by negative 1, and we get negative 0.016. So we can start filling this in. Our price is 47, D of P is 0.016, negative. Not that it matters because we have absolute value. And then we need the function at 47. So that's the square root of 4,000 minus 2 times 47. So 4,000 times, or minus 2 times 47 is the square root of 3,906, which is 62.5. Alright, so we just need to figure this all out. We have 47 times negative 0.016 divided by 62.5, and take the absolute value of that, we get 0.012. Except that I made a little error with this. My apologies. It should be 400, not 4,000. Alright, so that's going to change things here. I think the result will still pretty much be the same for elasticity, but alright, going back to d prime, it's going to be 400 minus 2 times 47. So 306 to the power of negative 0.5. So we get negative 0.06. And then if we just do d of 47, so that's going to be 400 minus 2 times 47, and we want the square root of that. That's 17.5. Alright, so 47 times negative 0.06 divided by 17.5 is negative 0.1611, but we're taking the absolute value of that, so it's going to be positive 0.16. And you might get a slightly different answer depending on where you rounded. But the result is going to be the same even if you got a slightly different answer. It's going to be inelastic. And we want to raise prices. So again, I'm sorry for using 4,000 instead of 400. Number 5, we are doing implicit differentiation of x squared plus y cubed equals negative 8. So if we take the derivative of both sides, we get 2x plus 3y squared y prime equals 0. Solving for y prime, we would subtract 2x on both sides and divide by 3y squared. So minus 2x over 3y squared. Number 6, a spherical snowball is melting in such a way that its radius is decreasing at a rate of 0.4 centimeters per minute. At what rate is the volume of the snowball decreasing when the radius is 14 centimeters? So volume of a sphere is 4/3 pi r cubed. If we take the derivative of that with respect to r, we're going to get 4 pi r squared times r prime. Now we just got to put the values in that they give us. So it's going to be 4 pi, and then the radius is 14, so 14 squared. And then it's the rate, r prime, is 0.4 centimeters per minute. And multiplying that all out, we should get 985.2. Number 7, we're evaluating the integral from 3 to 5 of 10x plus 3 dx. I would just use your calculator for this. If we do math 9, we're going to be putting in 10x plus 3, comma x, comma 3, comma 5. And we should get 86. Number 8, we have the integral of 5 over x to the 4th plus 7x plus 3 dx. I would just change it so it's the integral of 5x to the negative 4 plus 7x plus 3. make it more antiderivative friendly. So then we're going to get 5x to the negative 3 over negative 3 plus 7x squared over 2 plus 3x plus c. And we can't really simplify that, so that'll be our answer. Number 9. A company's marginal cost function is 19 over square root of x, which of course is 19x to the negative 1/2, where x is the number of units. Find the total cost of the first 81 units. So this one we can't use our calculator. It'll give us an error. So we're going to do 0 to 81 of 19x to the negative 1/2 dx. So if I add 1, it's going to be 19x to the 1/2 over 1/2, evaluated from 0 to 81. Well, that's the same as 38x to the 1/2, evaluated from 0 to 81. So if we plug 81 in, we're going to get 38 times 81 to the 1/2, which is 342. Plug 0 in, we get 0, so it's just 342. Number 10, we're given the demand function, 4,332 over root x, and the supply function, 3 root x. We want to find the equilibrium quantity, so we're going to set them equal to each other. Multiply both sides by square root of x, so we're going to get 4,332 equals 3x. Divide by 3, and we get 1444. Then it wants the producer surplus. So producer surplus is equal to your x times either d of x or s of x. It doesn't matter because they're both going to be the same, minus the integral from 0 to x of the supply function, so s of x dx. Well, I have x, but I don't have d of x. So d of x, or d of 1444, is equal to 4,332 over the square root of 1444. And when we do that, we get 114. So this is going to be 1444 times 114 minus the integral from 0 to 1444 of 3 root x dx. Now the second part we can do in the calculator because there's no 0 in the denominator. And of course we can easily multiply the first two numbers together. So we get 16. And then if I do math 9 of 3 root x comma x comma 0 comma 1444, calculator's being a little bit slow. It's 109,744. And I can subtract those. And get 54872. Number 11, we're trying to find the integral of 6 over x dx. That's one of your special ones. It's going to be 6 ln of the absolute value of x plus c. 12, we are given a function which is 2x cubed minus 24x squared plus 42x minus 7. It has two critical points. We need to find them. So we need to take the derivative, 6x squared minus 48x plus 42, and we need to set that equal to 0 and solve. You can use the quadratic formula by hand or use it in your calculator, where a is 6, b is negative 48, and c is 42. And we get two numbers, x equals 1, x equals 7. Number 13. Suppose a company's revenue function is given by r of q equal to negative q cubed plus 210 q squared. And its cost function is 400 plus 16q, where q is in hundreds of units sold / produced, while r of q and c of q are in total dollars of revenue and cost, respectively. We need to find a simplified expression for the marginal profit function. Well, first we need our profit function. So profit is revenue minus cost, so it's going to be negative q cubed plus 210q squared minus 400 minus 16q. We don't have any like terms, so that's fine. So to get the marginal, we're just going to take the derivative and get minus 3q squared plus 420q minus 16. So those are your two answers for this one. You need the actual profit function and then also the marginal profit function. You could switch these and put them in the descending order, but it'll take it either way. It's the same answer. Number 14 is the last one because we're not doing number 15. We get 210e to the 0.13x dx, and we need to find the antiderivative. Well, the derivative of e is e to the x, and so is the antiderivative. So it's going to be 210 e to the 0.13x, and normally we multiply by the derivative of its exponent, but with an antiderivative, for when we take derivatives, but when we're taking antiderivative, we actually divide by the derivative of that exponent, which is 0.13. So if you do 210 divided by 0.13, you're going to get 1615.4 e to the 0.13x. Oh, plus c. Can't forget our plus c. Number 2. A piece of cardboard measuring 11 inches by 8 inches is formed into an open top box by cutting squares with a side length x from each corner and folding up the sides. So we have a rectangular piece of cardboard, and it's 11 inches by 8 inches. So we're cutting the corners and folding it up to make an open top box. And we don't know how much we're cutting the corners, but they're square. So the dimension of the length and the width are the same for each corner. And the volume of the box is what we're trying to maximize, so that's what we need to find a formula for. Well, if I cut x from each side, then my longer side will be 11 minus 2x, because I'm taking away the dimension of x twice. And the shorter side will be 8 minus 2x. And then the height of the box will just be x. So that's our volume formula, but we need to actually FOIL it out. So it's going to be x times 88 minus 16 and minus 22 will give us a negative 38x plus 4x squared. And then distribute the x, we get 88x minus 38x squared plus 4x cubed. Excuse me. Yep. So if we take if we're trying to maximize the volume, then we want the derivative. So the derivative is 88 minus 38 times 2, which is 76. So minus 76x plus 12x squared. We need to set that equal to 0 and solve. I recommend using your calculator, the quad program for that. So A is 12, B is negative 76, C is 88. We get two dimensions. One is 4.81 and the other one is 1.53. Now if I put 4.81 in for my width, so in other words I'm taking away 4.81 on each side, I'm actually going to run out of material. So that one can't work. So the amount that we're going to cut from each corner to maximize the volume would be 1.53. Number 3. A baseball team plays in a stadium that holds 58,000 spectators. With the ticket price at $10, the average attendance has been 22,000. When the price dropped to $9, the average attendance rose to 29,000. Assume that the attendance is linear related to ticket price. So it means that attendance depends on ticket price. So our 2 points are going to be 10, 22,000, and 9, 29,000. Well, if it's linear related, then we can use that information and we can find slope and y-intercept. So slope is rise over run. So we're going to get 7,000 on top and negative 1 on the bottom. So we get negative 7,000 for our slope.